Alright, so we are starting chapter 7, and the first thing we're going to be talking about is direct variation and inverse variation. And you have actually seen direct variation, you'll realize that in a little bit. But what we want to talk about is what is the big difference between direct variation and inverse variation. So dV is direct variation, IV is inverse variation. And the first thing you need to know is that X is considered the input, it's our independent variable. And Y is our output, it's our dependent variable, and Y depends on X, okay? So the first thing we're just going to talk about is direct variation. So in direct variation is a ratio, and it's the ratio of the output, so it's a ratio of Y to the input of X. And you're always, when you have this ratio of Y over X, you're always going to get a constant, some same amount. And so for constant, I'm going to be using the letter K. Sometimes they use the letter A, like an apple. Sometimes they use the letter M. A lot of books do use the letter K for constant, okay? So the idea is, in direct variation, one variable increases, so for instance, as X increases, then the other variable also increases so that the ratio between the two can be the same. So for instance, if I just start comparing, you know, this y and x to this y and x to this y and x, then what happens is, if I use this formula that I just gave you, k equals y over x, then if I take, for this one, -5 over -1, or for this one, take y over x or y over x, then I always get the same amount. I always get 5, and that, as it turns out, is what my k is. Okay? And then you can go back and I'll show the other equation for direct variation, and it's this. It's y equals kx. And you actually have seen this before. It's similar to y equals mx plus b, but instead of m, they use k, and the y-intercept is always 0. So that's why 0, 0 shows up in here. So when I look at this equation, it's direct variation because when I compare the ratio of the y to the x's, I always get the same constant amount. I always get 5. And then I can write the equation for my direct variation. And again, an equation is y equals, and then the other stuff. So this would be y equals 5x. So it is just a line, and so that's why I said you had seen this before. It's a line, but the y-intercept is 0. And the y-intercept is when x is 0, and so y is 0. So you're always going to see 0, 0 in direct variation. If I start to put a slope in there, then this taking and the ratio of y over x isn't going to happen. You're not going to always get the same amount because you've got a y-intercept affecting it. Hopefully that makes sense. So what are some examples of direct variation? Well, anytime you get paid. So you get paid $8 an hour. So the amount you get paid varies directly with how many hours you worked. So first of all, which one is which? Which is X and which is Y? So the way to ask yourself this question is what depends on what? So the amount you get paid this depends on the number of hours you work. So for instance, if you work 1 hour, you get $8. If you work 2 hours, $16. If you work 3, $24. And if you work 4, that's $32. As X gets bigger, Y gets bigger. And this constant amount is the fact that it's changing by the same amount every single time. Okay? Because I'm basically just adding 8. But again, the constant is this ratio of y over x. So if you take 8 divided by 1, you get 8. If you take 16 divided by 2, you get 8. If you take 24 divided by 3, k is 8. If you take 32 divided by 4, k is 8. So in the end, k is 8. And if I were to write the equation that represents this situation, an equation is y equals 8x. So the two equations. One equation is the ratio one that helps you find k, and the other equation is the equation that represents the entire situation. All right? So you drive 60 miles per hour, and the distance you drive varies directly with how long or the time that you drove. So this is direct variation. So what's what? Well, basically, the distance you drive depends on how long you drive or the time. So if you're driving 60 miles per hour, cruise control is set. If you drive 1 hour, there's 60 miles. If you drive 2 hours, 120, 3, 180, 4, 240. So what's the equation? Well, again, there's this constant ratio. K is y over x. So 60 over 1, or 120 over 2, or 180 over 3, or 240 over 4. They always give me the same amount for k. K is 60. And then once I know k, I can write the equation that represents this direct variation, which is y equals 60x. And again, this whole idea about 0, 0. 0, 0 could fit in here technically. If you work, I don't know, let's just put it here. If you work 0 hours, then you're getting no money. Or if you don't drive at any speed, if you don't drive at all, so 1 minute, 2 minutes, if you drive no minutes, you've gone no miles. Okay, so you can kind of see how 0, 0 would still fit in these. So that's direct variation. Again, direct variation is a ratio between y and x. This ratio helps you find your constant, but then this is the equation. When they say write the equation that represents direct variation, this is what they're looking for. An equation is y equals. So let's go to inverse variation. So in inverse variation, there's another thing happening between y and x, but it's the product, and product is multiplying of the output and the input. So now to get k, I'm going to multiply y and x instead of dividing y and x. And when you multiply y and x, you're always going to get the constant. So if you're looking for the constant, this is how you do it. But again, when they want the equation for the inverse variation, now I need it to be y equals, and so I would just move x to the other side by dividing. So it's y equals k over x. So what's going to happen here is when you look at a set of numbers is as one variable increases, the other one decreases. Okay, and it could even be that this one's increasing if you go this way, and that means this one's decreasing that way. Okay, so the idea, this is inverse variation. One way I can see this is, again, this is increasing left to right, this is decreasing left to right. So that's kind of the first inclination that it's inverse variation. But how I verify it is I look to see if the constant between y and x is always a product. So if I multiply y and x, do I always get the same number? So if I multiply 2 and negative 12, that's negative 24. Or 4 and negative 6, that's negative 24. Negative 24, negative 24. So by going through each x and y and doing that product, I can see that k is negative 24. But when they want me to write the equation, again, I write the equation in the form y equals. So I just take y, and it's going to be negative 24 over x. All right? All right, so let's go and look at some examples. So the number of slices of pizza you get varies inversely with how many people there are to feed. So if there are 16 slices to a pizza, then, so first, what's x and what's y? Well, this is all about how many slices of pizza a person gets. So the number of slices you get, that depends on how many people there are. So for instance, if there's only one person, that person gets all 16 slices. If there are 2 people, then each person gets 8. I'm going to skip 3 because it's not a nice number. I'm going to go to 4. If there are 4 people, each gets 4 slices. And if there are 8 people, they each get 2 slices. So you can see as x is increasing, y is decreasing. So what's the constant? Well, you can go back to your formula that the constant is when you take your y and you multiply the x. So 1 times 6, there's 16. Multiply, you get 16. Multiply, you get 16. Multiply, you get 16. So k is 16. But when they want you to write the equation, they want you to use this version, y equals k over x. So it's going to be y equals 16 over x. All right? Let's look at another one. This is another driving analogy. So Colorado Springs is approximately 70 miles from Aurora. The time it takes you to drive to Colorado Springs varies inversely with the speed that you drive. So what depends on what? Well, this time over here they were comparing your distance and your time. So this is comparing your speed to your time. So what depends on what? Well, how long it takes you to drive there, the time it takes you to get there, that depends on how fast you go. So if you drive really slow, it's going to take you longer to get there because the mileage is set at 70 miles. But if you drive really fast, then it won't take you very long to get there. So your time depends on your speed because it's a set distance. So for instance, if you drive 70 miles per hour, you're there in 1 hour. I'm going to work with numbers that work well with this problem. So if you drive 35 miles per hour, then it's going to take you 2 hours to get there. Or if you drive 10 miles per hour, it's going to take you 7 miles to get there. Or if you drive 7 miles per hour, which we would never do, maybe you're running really fast or you're biking really slow, it'll take you 10 hours to get there. So again, what's your K? K is when you multiply y and x. So if we multiply, we're always getting 70. And then you can write your equation, y equals k over x. So where does 0, 0 fit in there? Well, this is kind of going back to that, almost like that Cookie Monster thing that you ask on Siri. So what happens if you do put 0, 0 in there? Well, if there are no slices of pizza, no people even need to bother showing up, okay? Or if you never drive, if you're not even going in the car, you're never going to get anywhere. No time's going to go by, okay? And if you think about it, the reason why 0, 0 is not going to work is because, you know, when you put 0 in for x, we can't divide by 0. So that's why 0, 0 is never going to appear here, but it can appear here, all right? So that's the first part of direct variation and inverse variation. Let's take a look at the graphs. Okay, so let's take a look at the graph. So I already wrote a couple things down. So what does direct variation look like? So I already talked about that direct variation. I told you it's linear. It's a line. Y equals kx is just like y equals mx plus b. M is now your k, and b is always going to be 0, 0, or 0. So if x is 0, y is 0. So we know it's going to be a line. Just looking at the information, how would I start to know that this is direct variation? Well, first, as x gets bigger, y is getting bigger, or as y is getting bigger, x is getting bigger. The way I'm going to definitely double check this, though, is I'm going to take and use that ratio of the constant. If I take all of these y's and divide it by x, I should get the same amount. So if I take -2 divided by -6, or -1 divided by -3, 0, 0 is not part of this because it's you're just going to look at the actual numbers. 1 over 3, 2 over 6. Then when I simplify all these fractions, I get 1/3. And that's what k is. K is 1/3. And now when I want to write my equation, it's y equals 1/3 x. Y equals mx, and then my b would be 0. So if you just go through and, for instance, and graph these points just from the table, -6, -2, -3, -1, we'll go ahead and put 0, 0 in there. 3, 1, and 6, 2, you're going to see that line. And the line is always going to go through the origin, the center, 0, 0. And if you look, what we know about lines is that there's a rise and a run. Up 1 over 3, up 1 over 3, up 1 over 3, up 1 over 3, etc. And you can see that here as your rise over your run. So it's direct variation for a couple of reasons. One is, I think it is because as x gets bigger, y gets bigger, but that's not the definite reason. The main reason I know is when I graph the points, first I see a straight line that goes through the center. The y-intercept is 0. But the main thing is just by looking at the table, when I do this ratio, I always get the same amount. So what does inverse variation look like? All right. So let's start first. How do I know this is inverse variation? When we talk about x getting bigger and y getting bigger, we're going to look at this a little differently, and you'll see why once we look at the graph. Because it can't be 0, 0, I'm going to look at this side. So as my x gets bigger, my y gets smaller. But then there's going to be a break in the graph, and you'll see the break in just a moment because we talked about why you can't have 0 in there. So here, when I look at the other side, after the break, as x gets bigger, y is getting smaller. Okay? So how do I know this is inverse variation? So first, the bigger, smaller thing that I just talked about, I can use that whole idea that k comes from the product of y and x. So if I multiply these, I get 2. 2. Half of 4 is 2, and a negative is 2. Half of 4 is 2, 1 times 2 is 2, 2 times 1 is 2. So by doing that, I'm always getting 2, so that is my k. And then the equation comes from y equals this over this. So what does this look like? This one's a line, so what does this look like? So I'm going to graph -2, -1, -1, -2, and then -0.5, -4. And what's going to happen is if you keep going, points smaller than -2 or bigger than -0.5, what's going to happen is you're going to start to see this shape. Okay? And then I'm going to graph 1/2, 4, 1, 2, and 2, 1, and you're going to have this shape. And so there's actually a break in the graph right here. The graph is never going to touch where on the y-axis or on the x-axis, because we've already talked about that x can never be 0 and y can never be 0. So why can't x be 0 and why can't y be 0? So I'm going to explain that now. If you go to the equation that we just graphed y equals 2 over x. Kind of looks like in the past they've called this the boomerang shape. It's actually called a hyperbola, and we'll get to that when we do our graphing section. But the idea is, first, x can never be 0. You can never divide by 0. So that's why x can never be 0. And there's nothing that I could put in the denominator to actually get me to 0 for y. So I can never come up with a number to make y become 0. So that's why, when you look here, we're never going to have a point here. On this x-axis, y is 0. You can go left and right, but you never go up and down. So y is never going to be 0. And here, on this line, this is where the x's are 0. And since x can never be 0, it never reaches. So we have what we've known as, in the past, something stopping the graphs. So again, the fact that y can't be 0. I know I'm highlighting the x-axis, but on the x-axis, the y's are 0s. And x can never be 0. On the y-axis, all the x's are 0. And these were called the walls. Well, you can't really see that. Or the asymptotes. All right. So real quick, and then that's it. I think that's it for these notes, right? Oh, no, we got a little bit more. Is just some things to think about. Inverse variation looks a lot like the exponential graphs that we did in the last chapter, chapter 6. So it looks like exponential decay. However, in an exponential decay function, so for instance, just going to make one up, this can have a y-intercept because I can make x become 0. A y-intercept is when x is 0. I can take 2 to the 0 power and get an answer. So this can have a y-intercept because x can be 0. But in a parent function of an inverse function, so just again the one that we did before, x can never be 0 because you can't divide by 0. So if x can't be 0, you are never going to have a y-intercept. Okay? So just a big difference between these shapes. Here there's actually 2 of them, and in an exponential there's only 1. And in an exponential you can have a y-intercept, but in this shape you cannot have a y-intercept. So just something to think about. All right, let's move on. So let's talk about how do you know if it's direct variation, inverse variation? None of them, because this is the stuff that you're going to see on the worksheet and on the tests and stuff like that. So what I want to know is, does it show inverse variation, direct variation, or neither? So think about those equations that we wrote. An equation first is y equals, okay? Oh, sorry, here's the other one, y equals. And in the equations, there's either division or there's multiplication. So just some things to think about as you go through this. So real quick, I'm going to write them up here so I don't have to look back and forth. Here's direct variations equation. Here's inverses variation. I'm not saying it anymore. I'm going with DV and IV now. So what does it show? So this is y equals 2 over x. That matches this. This is inverse variation. Now, if it is variation, I do want you to tell me what k is, and in this problem, k is 2. This is not an equation yet. I need it to be y equals. So to move the x over, I would just divide it. And once I do that, I can see that it's inverse variation with k being 12. When I go to this one, again, an equation is y equals, so I need to move the x. Since they divided by x, I'm going to undo that by multiplying by x. So multiply x, it's gone, multiply by x is gone, and now here's the equation. And that matches direct variation. So it's direct variation, and my constant is 8. This one, y equals everything, they're multiplying, so that's direct variation, and my k is 4. And in the last one, there's addition and subtraction. So this is actually neither. It is linear, and our m is 1, but since we have a y-intercept, it's not direct variation, okay? It's just linear. All right, so the next set. This chapter is mainly about inverse variation, but we show you direct variation so you can compare it to inverse variation. So when they say the variables x and y vary inversely, then use the given values to write the equation relating x and y. Again, when they say writing the equation, they want this equation. But you're going to have to use this equation from inverse variation to figure out what your k is. All right? And then once we do that, we're going to use it to find y when x equals 3. So first I need to find what k is. K is just going to multiply y and x. So if I multiply those, my k is negative 20. Now that I know k, I can write the equation. And now I'm going to use the equation to find y when x equals 3. So if this x equals 3, and I put 3 in here, my y is just negative 20 over 3, or whatever the decimal is of that. So again, next one, to find k, because I know they vary inversely. I'm going to have to multiply them. When I multiply these, I'll discover that my k is negative 24. Then I'll write the equation. And now if x is 3 in this equation, then I'll know that the y is 8. Okay? All right, so if x equals negative 4 and y equals 5/4. So again, I want to multiply them. So if you take negative 4 times 5/4, you'll be multiplying fractions in a little while. You're going to get negative 20 over 4, which is negative 5. So now that you know k is negative 5, you can write your equation. And then if x equals 3, and I put 3 in there, then my y is negative 5/3. And then the last one. So I'm not going to write the y equals kx anymore. I should multiply these. If you multiply, you're just going to get negative 35 over 3. That's what your k is. So when you write the equation, y equals negative, I can't even write anymore, 35/3. And then the 3 just joins the x in the denominator. Okay? And now if x is 3, and I put 3 down there, I get negative 35/9 for my y. Okay? So that's how you do inverse variation a different way. Just another way, kind of going back to the top. Here they give us an equation, here we get the table. So is it inverse, is it direct, or is it neither? So again, if I divide these, it's direct. If I can multiply these and get the same amount, it's inverse. So you might want your calculator here because not all the numbers are nice. So first I just always start with inverse. So if I take this and divide it by this, or this divided by this, or this divided by this, do I get the same amount? So if you don't have a calculator, you could start with these two. If I take y and divide it by x, I always get 9. And then I'm going to assume that the others are correct, but you could just double check. 67.5 divided by 7.5 you get 9 again. 22.5 divided by its x, you get 9. So since this is the equation that it works, this is direct variation, that 9 that I kept getting is my k, and now I can write the equation, but y equals 9x. This one, so is it direct variation? 21 divided by 4, none of these divide easy, so 21 divided by 4, I get that. 14 divided by 6, I get a different number. So it's definitely not direct variation. So then what I'll try is the other one, the multiplying them. So 21 times 4, 6 times 14, I'm getting the same number, 8 times 10 and a half. They're probably all going to work. So this one, so sorry, let me go back to this. This is my k, this 84 that kept showing up. Since the product version worked, this is inverse variation. And now I can write my equation. So the next one, first I'm going to start dividing. So 16 divided by 4 is 4, but 11 divided by 5 isn't 4. When I start dividing, I'm not getting any of them, so it's not direct variation. So then I'll start multiplying them and see if it works. So 16 times 4, 11 times 5, it's not going to work. So this is actually not direct variation or inverse variation. It doesn't mean that there's not an equation to it, but this one's neither. Okay? All right, so what is something you would see on the test, on the worksheet? So the number of songs that can be stored on an MP3 player varies inversely with the average size of a song. And a certain MP3 player can store 2,500 songs when the average size of a song is 4 megabytes. So first, what's your X and what's your Y? So the number of songs that I can store on my iPhone, for instance, is going to depend on the size of the song. So the number of songs is going to depend on the size of the song. Okay? So, for instance, just going through some of these, let's see. Okay, so anyway, sorry, that's all I want to do right now. There are steps over here. So, this is just kind of the scenario. I want to identify the variables y and x, so I did that. So, y is the number of songs. Kind of jumped the gun. Because the number of songs is going to depend, y depends on x. So, the size of the song. So now why does this situation represent inverse variation and not direct variation? Because the idea of this is the bigger the song size, so as x gets bigger, the number of songs that I'm going to be able to hold on my phone is actually going to have to go down, if that makes sense. So as song size gets bigger, the number of songs will have to go down. So that's why, for instance, on your phone, you can have pictures, but not as many videos, because videos take up more storage. So the more videos you have, the less storage you have. Whereas, your photos will allow you to have more storage on your phone. You can hold more photos than you can videos. All right, so use the given values. We're going to identify k. So, for instance, 2,500 songs, that's the number of songs. And y is, sorry, I take that back. Y is the number of songs. I messed that up. And x is the size of the song. So each song is 4. So if I can figure that out, now I can go to my equation where I multiply those two. And if I just multiply those two, I get 2,500 times 4 is 10,000. And this is my k. All right? So now what I can do is make an equation out of it. They don't ask me to, but we're going to need that. So y equals 10,000 over x. All right, so make a table showing the number of songs that will fit on an MP3 player if the average size of a song is 2 megabytes. Then they ask for 2.5 megabytes, 3. And actually, you know what? I think I'm going to change that to 4. Let's change that to 4. because it'll be a nicer number. So we're going to change this to 4 and 5. So the idea is if these are all of my x's, if these are all of my x's, I can plug them into the equation that we came up with and figure out how many songs I could hold. So first, 10,000 divided by 2, I can hold 5,000 songs. Let's get our calculator for the rest. So 10,000, I divide it by 2.5, I can hold 4,000 songs. If I take 10,000 and I divide it by 4, each song is 4 megabytes, I can hold, 4,000, 2,500 songs. And if each song is 5 megabytes, then I can hold 2,000 songs. So again, as the size of the song gets bigger, the amount of songs that I can hold on my MP3 player goes down. And that is direct variation and inverse variation.